All right, in this video, we're going to discuss the Pythagorean Theorem and how the Pythagorean Theorem is used. The theorem itself is a squared plus b squared equals c squared, and we want to look at where we can actually use that. So if we look at, first of all, a right triangle, which is where Pythagoras' theorem is actually used, we first of all have to be able to make sure we understand the parts. And the legs of a right triangle are the two sides that form the right angle. So if you notice this side right here in the bottom and the side that looks fairly vertical form a right angle, those would be the two legs. While the hypotenuse is always the one that you maybe would want to find first, is always directly across from the 90-degree angle. So if I find that 90-degree angle, go directly across, that has to be the hypotenuse. So once I label the hypotenuse, the other two sides of the triangle have to be the legs. When it comes to Pythagorean theorem, the two legs are known as A and B, and the hypotenuse is known as C. And the theorem itself then becomes, if I square A, which is one of the legs, and add to it the square of the other leg, so A squared plus B squared, that has to be the same as the hypotenuse, which is C squared. So we'll look at a couple of situations now how we might actually use the Pythagorean theorem. So let's say in this case, we are given a right triangle, and we know that this side down here is 3, this side is 4, and we would like to know what the side across from the 90-degree angle is. So in this case, if you remember, the side across from the 90-degree angle, this has to be the hypotenuse, therefore we have C. The numbers 3 and 4 can be A and B, and it doesn't matter which order. A can be here or A can be there, but one is A and one is B. So the Pythagorean theorem would say that we take one of the legs and square it, plus the second leg, which is 4 squared, should be equal to C squared. A squared plus B squared equals C squared. Our job now is to use a little bit of what we know about exponents. 3 squared is 9, plus 4 squared is 16, still equals C squared, and 9 plus 16 with a little bit of addition turns out to be 25. So C squared is 25, and the question really becomes, what number could you square to get 25? Or if you want to think in terms of opposite operations, if I take the square root of C squared, I will get C, and if I take the square root of 25, I would get 5. Therefore, C turns out to be 5, and if I move back to my triangle, the length of this side right here would have to be the number 5. So I'm able to figure out, based on the Pythagorean theorem, 3 squared plus 4 squared ends up being C squared, which is 5. Let's take a look at a second example here. And in the second example, again, I'm going to draw a right triangle. And we'll give it a little bit there. The right angle is here. We're going to let this be 13, and we're going to say that this is 5. And we'd like to know this side. So in this case, we know the hypotenuse is 13. Remember, the hypotenuse always has to be C. And these can be A and B in any order, so let's just call this one A and let's call this one B. So if that's the case, we don't know the side A, so I will say A squared plus the other side, which I know to be 5 squared, equals 13 squared. So this time I want to figure out what A squared is. So the way we're going to go about this is we will take A squared plus 5 squared is 25 equals 13 squared. 13 times 13 is 169. We're going to actually use a little bit of algebra here. And the algebra says in this case, if you're taking A squared and you want to get A squared by itself, you really want to get rid of the plus 25. And I talked a little bit in a previous video that dealt with percent word problems, that when you have an equation, what you do to one side, you must do to the other side. If I would like to get rid of this plus 25, I can do so by subtracting 25. The only thing is, if I subtract 25 from one side of the equation, I have to subtract 25 from the other side of the equation. And if I do that, I'm then left with the plus 25 and the minus 25 cancel out, so I'm left with A squared equals 169 minus 25 is 144. And now I'm at some number squared will be 144. Again, I can think of it, maybe I know my squares, and some number squared, what number times itself is 144. Or I think about taking the opposite of squaring, which is square rooting. And the square root of a squared is a, and the square root of 144 is 12, because 12 times 12 turns out to be 144. So I've now figured out that a is 12, which tells me right back up here, we'll use a different color, tells me right here that this side is 12. One leg is 12, the other leg is 5, final leg is 13, because 12 squared plus 5 squared equals 13 squared, which is what the Pythagorean theorem says. Hopefully this video helps. Again, if not, certainly research and maybe try to find another video or a little bit more help, or certainly always ask a teacher or appear in the classroom if you need additional help.